Okay, hello everyone. Let us now solve a polynomial equation of degree 4. Okay, so let us apply what we've learned so far. Okay, so we have here x to the fourth minus 6x squared. So notice that there is no cube. Okay, so we're lacking the cube term here. So minus 8x plus 24 is equal to 0. Okay, so let's try applying our rational zero theorem. Let's see if that works out. Okay, so what is our a0? It's 24, right? And our an is 1 again. So it makes things a little bit easier because it's 1. Okay, so let's write that out. Factors. Let's use another color so that it won't be too boring. So factors of 24. This is our a0, right? So what are those? So that would be, oh wait, so that would be positive negative 1, positive negative 24, positive negative 6, positive negative 4, and positive negative 8, positive negative 3. Okay, we also have a positive negative 12, right? So are there any more? So we also have positive negative 2. Okay, so there you have it. There's so many. Okay, so let's type in the other one. So the factors of 1. So that's our an. So which is just plus minus 1. Okay, so let's not, so therefore, so we're just going to divide all this by 1, right? So let's just write here possible rational zeros, right, is equal to, so I'm just going to copy this numerator here because it's basically the same thing. Okay, oh, it's a cut. I thought it was a copy, but it turns out it's a cut. Okay, let's try. Let's put that back there. Okay, so there you have it. Okay, so there are so many of this, right? So many, and you can try it if it satisfies the equation, or you can use synthetic division also. But there are more speedier ways in order to do this, and you can also use a graphing tool, for example, or you can graph it on your own. So in this case, we will use a graphing tool. And upon graphing, we will see that there is an x-intercept at 2, 0. Okay, so we know, so from this, we will know immediately that x minus 2 is a factor of our left-hand side of this equation. Okay, so now we can then use synthetic division, right? We can then use synthetic division to determine the other factor aside from x minus 2. Okay, so let's do just that. Let's use another color here. Using synthetic division, um, yeah, 2. Okay, so what are the coefficients? We have 1. So we have 0 here because the x cube. And then negative 6, we have negative 8, and then 24. Okay, so then bring down 1, then 2. 2, that's 4, then negative 2, and then negative 4, and then you have negative 12, right? And then negative 24. And this indeed is a factor. Okay, so now we have the coefficients of our the quotient right here. So let us use, we now have x minus 2 multiplied by x cubed plus 2x cubed, 2x squared. Okay, this is 2x squared minus 2x minus 12. So this is now the other factor. Okay, and then this is all equal to 0. So now we are left with another, the same problem again. So we have here x cubed and x cubed. So are we going to do the same method again? So for this particular example, not anymore, because as you can see in the graph, the graph just touches this particular 0 point. So what does that mean, right? So that means that the multiplicity of this 0 is even, right? So it's even. So there could be 2 of this x minus 2. Or there definitely is 2 of these. So let's verify that using a synthetic division. So let's do synthetic division once more. So use let's divide this by x minus 2. So we have here 1, 2, negative 2, and negative 12. Okay. So we have, sorry for that. So we have here 1, multiply that. So we have here 4, and then 4 times 2, that's 8, and then 6 times 2, that would be 12. And this indeed is a factor still. Okay, so let's rewrite our equation again. So now we have x minus 2 multiplied by x minus 2. Oh, let's write that properly. X minus 2 multiplied by x squared plus 4x plus 6. Okay, so if we can factor this out, and then we are done, right? So what is this? X plus 3. So I don't think we can factor this using methods other than the, let's just use the quadratic formula here. Okay, so the quadratic formula, so we have a is equal to 1, b is equal to 4, and c is equal to 6. So that quadratic formula is a negative b plus minus b squared minus 4ac over 2a, right? So we have negative 4 plus minus 4 squared minus 4 times 1 times 6, and then 2 times a, that would be 2. Okay, so we have right here x is equal to negative 4 plus minus square root of 16 minus 24. So that would be negative 8, right? And 2. So this will be negative 4 multiplied by 2 square root of 2i, right? And then this will be 2. Therefore, we have here negative 2 plus minus square root of 2i. Okay. So now we have here, so now that we've found out the roots of this particular expression right here, let's just use the zero product property for these two, and then this will be the same, right? Just a multiplicity of 2. Okay, so therefore our solution set is equal to 2 and negative 2 plus minus square root of 2i, and then negative 2, plus, and then we have here minus square root of 2i. Okay, so this is our solution set. Now you might be wondering, why didn't you list 2 again? So let's review the elements of a set. You don't write an element of a set 2 times. So that's the definition of a set. You can't repeat an element within a set. Okay. So, but if you really want to write out all of it, so you can just write a 2 to this one and this one. Okay. So that's 4 roots in total with a 2 with a multiplicity of 2. Okay, so that's all for this video, and I hope you learned something new, and see you all in the next video.